Okay, let's work this example. We have here two identical masses. They are in dark blue here. They are both 2 kilograms each. And we are told that the distance from the axis of rotation that's pointed as x is 1.0 meters. And we are told to assume that this light blue rod that's holding them has zero mass. Okay, that's what they tell us. And they are asking us for the rotational inertia of the system of both masses. So in this case, the rotational inertia is going to be I1 plus I2. Since both masses are identical and are the same distance away from the axis of rotation, is just equal to twice I1, or I1 is just equal to I2. And I1 is just equal, the formula for moment of inertia is mr squared. In this case, m is 2 kilograms and r is 1 meter. So it's going to be 2 kilogram times 1 meter squared, so 2 kilogram meter squared. And my overall inertia is twice that, so it's 4 kilogram meter squared. Okay, now let's work this other example. Now, it's the same situation, but we would like to spin the system about the center of one of the masses. My axis of rotation is now here. Remember, the masses of each of the masses is 2 kilograms, and we are told to assume that the masses are tiny compared to the graphic, and we should ignore any effect the radius is going to have. Now, the moment of inertia is going to be moment of inertia of mass 1, let's call this mass 1, plus moment of inertia of mass 2. The moment of inertia of mass 1, like we did before, is going to be m1 times r1 squared, which is in this case 2 kilogram, and r1 is going to be this distance, which is 2 meter squared. 2 squared, that's 4 meter squared, times 2, so 8 kilogram meter squared. Note first that this moment of inertia is larger than what we calculated here. It's much larger for that same mass, and that's because I have a larger distance away from the radius of rotation. For the second mass, I2 is going to be m2 r2 squared, which is going to be 2 kilograms, but the second mass does not have any distance away from the axis of rotation, so r for that second mass is 0. So I2 is 0. My overall moment of inertia then is just 8 kilogram meter squared. The third example, we have two different masses. This one here is 2 kilograms. This distance here is 1 meter. This distance here is 2 meters. And this mass is 4 kilograms. And we are still ignoring the mass of the rod connecting them. It's 0 kilograms. Again, using the same rule, moment of inertia is I1 plus I2. If the rod had a mass, it would be plus I3, which would be the moment of inertia of the rod. Now, I1 for the red mass is going to be m1 r1 squared, and in this case we said that's 2 kilograms times 1 meter squared, which gives us 2 kilogram meter squared. I2 is m2 r2 squared, M2 being the blue mass, so that's 4 kilograms, and R2 being 2 meters, so that makes it 2 meters squared. 2 meters squared, that's 4. 4 times 4, that's 16 kilogram meter squared. That gives us an overall I of 2 plus 16, that's 18 kilogram meter squared.